All right, let's try another one. So, next one, example 2. So, I'm going to draw a circle. And now I'm going to put a hexagon inside of it. So watch, hexagon 6 sides. I'm going to go there. 1, 2, 3, 4, 5, 6. It's a hexagon inside. And then I'm going to give you a measurement. So I'm going to give you, in this case, that measurement right there. I'm going to tell you that, say 10. Okay. So, and the problem is going to say, what is the probability that you end up in the hexagon? Now, I'm hoping you guys see, the hexagon is such a big part of the whole that it's really likely that if I just chose places, I'm going to end up in the hexagon. So this number should come out to be a really big number. Like, it's not going to be 4%. Like, if I start hitting dots here and just choosing dots, most of them are going to be in the hexagon. So this will be a big percent. So here's what I got to do. I got to find the area of the hexagon. Area of the hexagon. And I'm going to put that over the area of the circle. So area of a hexagon is 1/2 PA. We've done that before. And a circle, we said, is pi r squared. Now, you're going to have to pay attention closely, guys, to what I give you. That 10 goes from the center to the circle, so that is the radius of the circle. So you're going to be good to go for the bottom. That 10, though, is also the radius of the hexagon, which isn't part of this formula. So don't go putting 10 in for the apothem. You're going to have to find the apothem and find perimeter, just like we were before when we were doing those kind of problems. So be careful with what I give you and make sure you use it in the right place. So up here, I'm going to do 1/2 perimeter times apothem. I don't know either of those. The bottom is pi times radius squared, which I do know. And I'll figure that out in a little bit. All right, now I'm going to focus on the hexagon. Now this becomes exactly what we've been doing recently. You're just finding the area of that hexagon. So you're going to draw this triangle and you're going to find the area, all the things that you need like we've been doing. So here's my hexagon. I'm going to focus in on just that triangle where I know this is 10. I know this is the apothem. That's half the central angle, and this is half of a side, which will get me my perimeter. So I'm going to find central angle is 360 divided by 6, which is 60. So that's a 30-degree angle. Now I can do trig to find my apothem, to put it here, and to find x, which will get me my perimeter. So it's all the same stuff we've been doing. So I'm going to do, I'll do the apothem first. So I'm going to cover that up. I'm going to go cosine of 30 equals a over 10. Multiply both sides by 10, and I'll know the apothem. So 10 times the cosine of 30 is 8.7. Good. So this apothem, 8.7. Now I've got to find the perimeter of that figure. Remember, you find the perimeter by finding this guy right here. If I find that guy, that's my x. That'll be this. I'll double it to get the whole side. Then I'll multiply it by 6 sides, and I'll have my perimeter. So I'm going to find that using sine. So sine of 30 equals x over 10. Multiply both sides by 10. 10, the sine of 30 is 5. Okay. Now that is not your perimeter. That is this, 5, right here. So what that means is the whole side is twice that. That'd be the whole side here, would be 10. And then if I multiply that by the 6 sides, 60 is my perimeter. So that goes here. Okay, now I'm ready to go. Now we go to our calculator. All right, put the top in first. I got 1/2 0.5 times 60 times 8.7. 261. There's your top. Your bottom has to be bigger than that, guys. If your bottom is ever smaller than your top, then one of them's wrong. Because the bottom is the area of the whole thing, which is always bigger than the top one. So I have pi 10 squared. So pi times 10 squared, 314.2. Divide them and multiply by 100, and that'll be your final answer. So I got 261 divided by 314.2 times 100. You got an 83.1% chance. 83.1%, which makes sense because if you look at the figure, it was gonna be a big percent. So, that's not really that surprising that it's a big number. All right, one more example. I'm gonna do it the other way around now. So in that problem right there, I put a figure inside a circle. Now I'm gonna put a circle inside of a figure. So I want you guys to do your best at this. They don't have to be drawn great, as long as you know what you're given. I'm gonna draw a pentagon, 5 sides. 1, 2, 3, 4, 5 sides. So here's the pentagon, and I'm gonna put a circle inside of it. So like I said, up here, the figure, the polygon is inside the circle. Now I'm gonna put the circle inside the polygon. So, you won't draw these great, but it'll barely touch there, barely touch there, that side, and there we go. Okay. And now I'm gonna give you one measurement. I'm pretty much always only gonna give you one measurement. I'm gonna give you this. From there to there is, say, 15. And that's it. It's all you're given. So what I'm going to ask you for is always the smaller one when you're doing probability. What's the probability of falling in the circle? Which means you're going to find the area of the circle. And you're going to put that over the area of the whole thing, which in this case is the pentagon. Area of pentagon. All right. Sorry, you guys couldn't even see that. Sorry about that. All right, area of a circle, got to know the formula. Pi r squared. Area of a pentagon, 1/2 PA. So look at what I gave you and decide if you have any of that stuff. So this one I need pi times radius squared. This one I need 1/2 times the perimeter times the apothegm. All right, so that 15, is it any of those? I look at it, it goes from the center, it touches the circle, that's called the radius. So that would be the radius of the circle. So that's gonna go here, 15. Is it anything for your pentagon though? So now, when you look back to the last problem, go back to this last problem, that 10 I gave you, that was the radius of the circle and the radius of the pentagon and radius or hexagon, and radius isn't in our formula. So, we used the 10 to get the things that we needed, but it wasn't one of the things we needed. In this problem, it is though, because that 15 is the apothegm of the pentagon. So when the circle's on the inside, the radius of the circle is the apothegm. So you always got to just kind of look at what you have. So pretend like the circle wasn't there at all. What does that 15 do? It goes from the center point, touches the side, not a corner. So that would be the apothegm. So I know that. I can fill that in right now. This is going to be an easier problem because you already have the apothegm. So the only thing I need in this problem is I need to find the perimeter, and then I'll be able to do the whole problem. So I'm going to create this triangle again, just like we always do, and I'm going to find